Hello and welcome to today's science lesson. So first of all, guys, can we all turn to wave and say a big hello to our friends on camera? Hello. And we'll begin by doing our meditation sequence. So I will sit down, take 2 fingers, find our heart center, left hand on our laps, and close our eyes. When you're ready, guys, you can open your eyes and come back to the room. And next we'll do our stretch sequence. So let's stand up and push in our chairs. And we can begin by stretching up high to the sky. High as we can. And then let's go back down. Touch our toes. Back up high one more time. And this time, can we go tippy toe high? And while we're there, wave side to side. And then back down to touch our toes again. And let's stand up straight. Shake it out. Arms and legs, shake it out. Now we can do some rotations. Left, right, left, right, left, right, left, right, left, right. Excellent, guys. And now for some stretches. So we'll do 5 to our right. 1, 2, 3, 4, 5. And then 5 stretches to our left. 1, 2, 3, 4, 5. Excellent, guys. And now we'll take our right hand and find our left foot. Then our left hand can find our right foot. Right hand, left foot, left hand, right foot. Right hand, left foot, left hand, right foot. And to finish, guys, we will do 5 claps. 1, 2, 3, 4, 5. Very good. Have a seat. So welcome to today's science lesson. But who can remember, what did we learn about in our previous science lesson? If I do this with a pen, who can tell me what is happening? Gravity. Yes, remember, we learnt about gravity. So let's write that phrase on the board first. Gravity. G-R-A-V-I-T-Y. Now there's a certain force that is used to pull things back to the earth. When I throw the pen in the air, it will come down. Does anybody know the name of that force? Gravitational forces, right. Gravity represents gravitational, A-V-I-T-I-O-N-A-L. And then force, F-O-R-C-E. So all together, guys, gravity and gravitational force. Yes. Now, who can remember the rule? What did we say about gravitational force? About things that go up. What goes up must come down. Yes, you see? What goes up must come down, because that's the rule of gravity that we have on planet Earth. So the rule of gravity, what goes up, H-A-T, what goes up must come. So altogether, what goes up must come down. As I've demonstrated several times with the pen already, the pen will go up and the pen will go down. But who can tell me some more examples of objects that go up and then come down? Airplanes. Very good example. If we go to an airport, we can see many planes taking off because they are jet powered. But eventually, before they run out of fuel, what will happen to them? They will go down. They will come back down. So aeroplanes is a very good example. Oh, P-L-A-N-E-S. Aeroplanes will go up and aeroplanes will come back down. A kite, yes. On a windy day, it might be nice to fly a kite. And the kite will go up, but once the wind stops, what will happen to the kite? Come down. Excellent, Latgal. Well done. So a kite is another example. Any other examples? Football, yes. Any type of ball, really. We could use a tennis ball, a badminton shuttlecock, or a baseball. Any ball we throw into the air, eventually it's going to come down. So a ball is another example. And what about us? People, yes. What happens if I jump into the air? Do I stay in the air? What happens? I come down. See? I go up. Then I come down. So people are also controlled by gravity. Anybody think of any other examples? A pen. Yes, as I've demonstrated before, a pen. There are millions of different things that we can think about. Literally everything is controlled by gravity. So all of these things here, they will go up and then they will come down. But who can tell me of some objects they can see in the sky that don't come down? Stars. Do stars come down to Earth? No. Stars stay in the sky. Anything else? Clouds. Yes, clouds. We can see lots of white clouds in the sky. Do they come down to Earth? No. How about the big yellow shiny bright thing at daytime? The sun. Yes. We have the sun. But at night time, the sun disappears. And then what can we see? The moon. So here we have some planetary objects that do not come down to the Earth. Does anybody know why gravity does not control these objects? Because they're outside the Earth's atmosphere. Gravity is only a force that controls things on the Earth. When we go high up into the sky, for the stars, the sun, and the moon, and also the clouds, they go up, but they don't come back down. So here we can see that we have things that are controlled by gravity and other things that are not. So let's practice speaking first. The things that are controlled by gravity include aeroplanes, kites, people, pens, and balls. And there are literally millions of objects. Everything in our classroom now is controlled by gravity. Anything in the classroom we put into the air, it will come back down. But planetary objects outside the atmosphere are not controlled by gravity. such as stars, clouds, the moon, and the sun. So we can see that gravity and gravitational force only affects things on planet Earth. That's why when we look into space, you can often see things floating about, because gravity does not apply there. So that was excellent, guys. Very well remembered. And what we're going to do today is we're going to move on, and we're going to look at the rate at which things come back down to Earth. We're going to look at two different types of functions. The first one, mass. Yes, mass is the amount of matter inside an object. And later we'll move on to look at weight. Okay, so even though they're similar things, they're not the same. First we have mass. Yes, and then we have weight. Okay, so it's important to know the difference between the two. And what we've got now is a PowerPoint presentation for our students to read about, listen, and also practice speaking about mass and weight and the way it affects different objects and in relation to gravity too. So let's all turn our chairs to look at the PowerPoint presentation, guys, on the TV screen. So now let's take a look at our PowerPoint presentation about mass and weight, lesson number 1. Now, who can remember what this object is here on the TV screen? Do we remember the previous lessons when we've tried to weigh things? Scales. Yes, this is a set of balanced scales. And what we do is we put objects on either side, and the object that weighs the most will go down. The object that weighs the least will go up. This is what we mean by balanced scales. The mass of an object is the amount of matter in the object. Yes, mass relates to matter. The definition of mass is the quantity of matter. And the way that we can measure how much mass is in something is through scales or a balance. And usually the unit of measurement is kilograms or grams. Now have a look here at this balance scale. Which one do you think has the most mass? The one on the left or the one on the right? On the right is correct. This has the most mass because you can see it goes further down. The one with the most mass will move down towards the ground using gravity. And the one with the less mass will go up into the air. Because this is what we mean by balance. Most mass will go down, less mass will go up. The more matter an object has, the greater mass it has. So have a look at the scales now. Which object has the most mass? The blue ball or the green pear? Correct. Because which one's lowest? The blue ball. So the blue ball has the most mass because gravity is bringing it down towards the earth. And the one with the least mass is going up into the air. This is what we mean by balance. The greater mass an object has, the harder it is to move. What can you see in the picture? A car and a man. What's the man trying to do? He's trying to push the car. Do you think he can push it? No. Why? Heavy, because it has lots of mass. Yes. If it was a cup or a ball, do you think he'd be able to push it? Yes, because the cup and ball have less mass. But objects with great mass are harder to move. The trolley is easy to move or change its direction when it's empty. Yes, you can see here. What can you see in the trolley? Nothing. The trolley is empty. Has anybody ever been shopping before with the trolley? Yes. And when there's nothing in it, is it easy to move? Yes, easy to move and turn because less mass. But what happens when we start putting things inside? The mass of the trolley becomes greater when it has matter in it. Yes. Is the trolley empty now? The trolley's empty? The trolley looks full to me. Do you think the trolley is easy to move now that it's full of objects? No, it's hard to move. Which trolley is easier to move? This one, the empty one, or the full one? The empty one. Well done, because it's got less mass. So the less mass, the easier they are to move. Therefore, the more mass an object has, the more it resists changes in motion. Yes. What two objects can you see here? Bicycle and a bus. Now, which one do you think has the most mass? The bus. So which one is easy to move? Bicycle. Yes. When we're on a bicycle, it's easy to turn the bicycle any way we want because the bicycle has less mass. However, when we're on a bus, and if we're trying to drive the bus, it's very hard to turn and takes big circles because it has more mass. So remember, guys, the more mass an object has, the more it resists changes to motion and is harder to turn. Any questions, guys? That was excellent. Very well done. Welcome back to class. We hope your students enjoyed the PowerPoint presentation so that they can learn more about mass and weight. And in this lesson, we're focusing particularly on mass. So remember, guys, the most mass in an object means the most matter. And the more mass or the more matter in an object, the harder it is to turn and maneuver. And now it's time for our stretch sequence. So let's stand up, guys, and push in our chairs. And for this sequence, we can have a game of Teacher Says. So listen carefully. If Teacher says, we can do. If Teacher doesn't say, don't do. So, hands on head. Hands in the air. Hands down. Teacher says, hands in the air. Teacher says, touch your toes. Stand up straight. Excellent. Teacher says, stand up straight. Teacher says, turn around. Teacher says, turn back the other way. Teacher says, jogging on the spot. Arms in the air. Teacher says, arms in the air. Arms down. Teacher says, arms side to side. Teacher says, arms backwards and forwards. Arms backwards and forwards. And stop. Teacher says, stop. Teacher says, arms by your sides. Teacher says, stands on one leg. Teacher says, hands on head. Teacher says, touch your nose. Swap legs. Teacher says, swap legs. Teacher says, stand up straight. Arms by your sides. Teacher says, arms by your sides. And teacher says, down into a ball. 5, 4, 3, 2, 1. And teacher says, jump. Excellent, guys. And teacher says, please sit down. And teacher says, it's now time for our flashcards activity, where what we're going to do is have our students put into teams and have them practice how to form sentences and practice speaking them also. All of the sentences are relating to maths, and they're sentences they've seen already in the PowerPoint presentation. So teachers, what you'll need to do is print off 2 sets of each flash sheet. Have 1 set to place on the board on display, and the next set we'll give to our students in pairs and have them work out how to put the words together. So first of all, let's take a look at our sentences. So our first sentence, the greater mass an object has, the harder it is to move. Okay, so the greater the mass, the harder to move. And then we have the mass of an object is the amount of matter in the object. So the more mass means the more matter. And remember when we learned about matter, solids, liquids, and gas. So the more mass, the more matter. In our next sentence, the more mass an object has, the more it resists changes in motion. Remember back to the PowerPoint about the trolley. The empty trolley we can turn quickly, but if the trolley is full, it's harder to turn. That's what we mean by the more mass, the more it resists changes in motion. And then our next sentence, the trolley is easy to move or change its direction when it's empty. Yes, when a trolley is empty, it's easy to change its direction. And finally, our fifth and final sentence is, the more matter an object has, the greater mass it has. That's the golden rule of mass. The more matter is the more mass. So these 5 sentences are what we're going to give our students in individual words. So for the second set of flashcards, teachers, cut all of the sentences into individual words. Then put your students into pairs or teams of 3 for large classes. So we've got Bangpon and Lakgao is team 1. Chu and Nadia, team number 2. And we've got Pat, Pak Bung and Net, who are team number 3. So let's see. Here we go with team number 1. But remember, guys, you have to wait until everybody's ready. And then our next ones are with team number 2. You're welcome, Nadia. And team number 3, you're welcome, Pak Bung. So all 3 teams now ready? Team 1 ready? Yeah. Team 2 ready? Ready. Team 3 ready? So remember, guys, your sentences are on the board behind you. So after 3, get ready. 3, 2, 1, go. So let's see if we can work out which sentence each team has first. And when you're ready, raise your hand. And then we can practice speaking. So try to find the first couple of words. The first word for every sentence is the. So the greater mass an object has, team 1. The mass of an object, team 2. And what's it? Let's see. Okay, so what have we got here? The greater mass an object has, the harder it is to move. Well done, guys. That was great. And team number 3, the more mass an object has, the more it resists changes in motion. Brilliant, guys. Very well done. And team number 2, the mass of an object is the amount of matter in the object. Excellent, guys. All 3 teams correct and very well spoken. So what we can do now is we can get our teams to collect their cards and pass them on to the teams on the left for the next round. So teachers, you can pause the video in your class now and do the same activity with your own students. And remember to get your teams to swap cards after each round, so all students get to practice forming and speaking each sentence. So are we ready, guys? Pakbong, I'll take yours and pass them to team 1. Not yet. And then for team 2. Okay, well done, Chu. And team 3 are ready. So team 1 ready? Team 2 ready? Team 3 ready? 3, 2, 1. Go. So another sentence. Let's see which one we're working on now, guys. All of our sentences relate to mass. The mass of an object, the amount of matter in an object. Wow. The mass of an object is the amount of matter in the object. Brilliant, guys. Very well done. Team 1. The more mass an object has, the more it resists changes in motion. Very well done, guys. That's correct. Okay. The greater mass an object has, the harder it is to move. Brilliant, guys. Very well done again. And one more time, let's collect our cards and pass them to the teams to our left. And next, I'll take yours and pass them on to team 1. Okay, so team 3 ready? Team 2 ready? Team 1 ready? 3, 2, 1. Go. Excellent, well done. The greater mass an object has, the harder it is to move. Excellent, Pakbong, Pat and Net, well done. The more mass an object has, the more it resists changes in motion. Brilliant, guys. Nadia and Chu, very well done. And team 1, the mass of an object is the amount of matter in the object. Very well done, Lakau and Pangpon. Guys, that was brilliant. Give yourselves all a big round of applause. And now it's time for our worksheet exercise. So teachers, what you'll need to do is give every student in your classroom their own worksheet. And what we're asking them to do is to answer a series of problems relating to the mass of fruits. There are a series of different fruits, and all of the different fruits have a different mass. What we want our students to do is to look at the diagrams and then answer the questions in relation to mass. Now, it's important to remember, guys, each square on the scale is 1 unit of mass, okay? So when you're counting the squares in each of the diagrams, 1 square is 1 unit. So we'll give our students around 12 minutes for this activity, and teachers monitor the class, help them with anything they need. But what do we need to do first, guys? Names on top first of all. So Bang Pong, this one's for you.
Thank you.
You're welcome. Chu, this is yours.
Thank you.
You're welcome. Nadia, this one's for you.
Thank you.
You're welcome. Pat, this one's for you. You're welcome. Pakung, for you. And finally, Net, this one's for you. So names on top, guys. Then have a look at the diagrams of the different fruits. And remember, 1 square is 1 unit of mass. So the first question, the mass of the pineapple is how many units? Where's the pineapple? So how many, and can you say how many units on the next scale? How many units of mass is the pineapple? 6, correct. Well done, Lakau, because the 6 units and the pineapple are the same. So you can see the pineapple measures 6 units. 1 square is 1 unit of mass. So the pineapple weighs how many? 6. The pineapple has a mass of 6 units. Now try to find which fruit is 2 units of mass. Tomato, are we sure? Correct. You can see the tomato is the same as 2 units. O-M-A-T. Oh, perfect. So we know the pineapple is 6 units of mass. The tomato is 2 units of mass. But what about the broccoli? No. Now have a look at the broccoli. What can you see on the next scale to the broccoli? Excellent. How did you get to 4, Pak Bung? Because a tomato is 2 units. 2 tomatoes is 4 units. Perfect. Very well worked out. You see, because 1 tomato is 2 units, Pak Bung worked out that the broccoli is same as 2 tomatoes, so that means 4 units. So what is 1 unit lighter than the tomato? If the tomato is 2 units, what is 1 unit lighter? 2 minus 1 equals? So what fruit or vegetable? The carrot, yes. The carrot is only 1 unit of mass. R-O-T. So now you have to think, you have to use your thinking skills. 4 items. Okay. So if we add all the 4 items together, we've got tomato, how many units?
2.
Broccoli, how many units?
4.
Carrot, how many units?
1.
Pineapple, how many units?
6.
So add them all together, what can you get? Yes, well done. All of the items together are 13 units. Excellent, guys. What's lighter than the tomato? So something that doesn't have as much mass as the tomato. Yes. The tomato is 2 units. So what is less than the tomato? What only has 1 unit? the something is lighter than the tomato. So how many units for the tomato? Two. So what's less than the tomato? And that's the... And what's this? Carrot. The carrot is lighter than the tomato. The carrot has less mass than the tomato. Than the tomato. So 3 times heavier than the tomato. So how heavy or what mass does the tomato have? Perfect. What mass does the first pack bung? Let's do it step by step so everyone knows. How many units of mass for the tomato? 2. So what's 3 times 2? Equals 6. So what has 6 units of mass? The pineapple. Well done. Welcome back to class. We hope your students enjoyed the worksheet activity where they had to look at the different items and decide of the different masses and also how the different items relate to each other by working out the different masses. My students here all did an excellent job, so very well done, guys. And that's all we've got time for today. So we hope you've enjoyed the lesson and now understand more about maths. And remember, maths always relates to the amount of matter inside an object. And we'll see you again soon for the next science lesson when we'll look at weight. But for now, can we all turn to wave and say goodbye, guys? Bye-bye. See you again soon.